The Celsius scale of temperature is based on the convention that 0 degrees is the freezing point for water, and 100 degrees Celsius is the boiling point of water. But there are other temperature scales. In addition to the Celsius scale, we have the Fahrenheit scale, where freezing is 32 degrees and boiling is 212. And even beyond that, we have one more scale, the Kelvin scale. If you look at the graph, this is a graph for 3 different gases, where each of the gases is in a rigid container. Now, why does it have to be a rigid container? Because we want the volume to remain constant for the gas. These could be volumes of gas that are held by very rigid metal cylinders. Let's imagine we take our sample of gas and apply a flame to it in one case and plunge it in some ice water in another case. This would change the temperature of the gas, but the volume of it can't change. What changes in the gas? So what can that look like? Well, remember that temperature is proportional to the speeds of the particles in the substance. So if you are to heat that substance and the temperature goes up, then the speeds go up too. Now, what will be the effect of this? There'll be more collisions with the container walls, and they could collide more forcefully with the container walls. If you cool the particles down, though, then they're going to have very short arrows, which indicate very slow speeds. So in that case, we would have less collisions with the container walls and less force when they do collide. What that tells us is that the pressure is changing. And there's a graph below showing how the pressure changes with temperature for 3 different gases. Not all gases exhibit the same type of change. But one thing they do have in common is that if you graph their changes in pressure with temperature, all of them will extrapolate back to the same point. And that is a point at which there is 0 pressure. It's a really important point in physics, and that temperature is so important that it's given the name absolute 0. It's supposed to mean no kinetic energy of the particles. So it turns out that 0 on the Celsius scale does not actually correspond to 0 energy. And that's what the Kelvin scale is for. The Kelvin scale calls absolute 0 Kelvin. So this formula here tells us how to convert a Celsius temperature to a Kelvin temperature. You have to actually add 273.15 to the Celsius temperature to get the temperature in Kelvin. So just for example, take 0 degrees Celsius. What does that correspond to in Kelvin? We have to add 0 plus 273.15. And then you get approximately 273. What if you take the 100 degrees Celsius and you want to know what that corresponds to in Kelvin? Well, just add 273 and you get 373 approximately. So those are the numbers that correspond to freezing of water and boiling of water in the Kelvin scale. Now let's find a formula for converting Kelvin back to Celsius. Well, what would you do with that 273 Kelvin if you want to get back to a Celsius temperature of 0? You'd subtract. And that's the formula. The temperature in Celsius is the temperature in Kelvin minus 273.15. There's also a little bit more complicated formula for converting between Fahrenheit and Celsius. This says the temperature in Fahrenheit is 9/5 the temperature in Celsius plus 32. Can we use algebra to convert Fahrenheit to Celsius? The first step would be to subtract 32 from both sides. The next step would be to multiply by 5/9 on both sides. That leaves us with our final formula. 5/9 TF minus 32 is TC.